And that's because when we first turn on an electrical load, we have a portion known as the inrush current. And if the inrush current exceeds that 500 milliamps, which it likely does with a component like this, an electrical load like this, there's a chance that you could blow that 500 milliamp fuse. Hey folks, how's it going? For those of you that are new, my name is Luke, and today we're going to go over all the different test settings on your Klein Tools MM450. Now, I just had the MM750 on the show, which is a very similar model to this, so I'm not sure if you're out doing research or if you already purchased them. The 750 does have some more features, but it only takes 2 AAA batteries, and it just eats through them, and you're not going to get through a day of testing with that meter. So what I'm looking for on the 450 is hopefully it has some better battery life. Maybe it takes at least 2 AA batteries. But anyways, with all that being said, let's get into it. Okay, I'm a fan of the big display. There is no kickstand. There is a mount for your magnet. Kickstand I don't think is a big deal. It is, again, the AAA batteries. Okay, something I am liking. I'm seeing this more common. It's going to let you know for the different settings that you're utilizing which ports you should be in. The 10 amp should be the only time that you have to use this port. All the other settings should be these two. But I like that. They're off to the side. That's kind of slick. Black goes in your COM port. And then your red lead is going to go down here in this main port. It's going to live there most of the time. I do like the design. Now, something that they keep doing because they have these weaker batteries in here, it defaults to a dimmer setting. So you got to be on the lookout for that, which is really annoying. It's also going to default to AC mode. So if you're messing around, let's say you're doing DC current and you're going from 10 amps to milliamps and you forget to hit your DC button, that'll get you. So remember, all the settings in orange on the dial, you'll have to use the selection switch to get to. Let's just go ahead and roll with some volts AC. Let's get this on the brighter setting for you. Volts AC measurements. Now you're probably thinking about taking a measurement outside directly from the outlet. I get that. I would ask that you use an outlet tester. You can get them really inexpensive. They have GFCI testing on them. This one's really nice by Klein. It's got GFCI and AFCI testing, which AFCI is a lot more common. If you're not familiar with it, I've got a video on this guy. Because testing from the outlet with your meter is a pain and it's not very accurate, but it can be done. So I'll go ahead and walk you through that process now. Since we're in AC, alternating back and forth, lead polarity doesn't matter which goes where, okay? Just don't short them out together. It is best practice to put your red to the hot, but if you don't know which one's going to be your hot and which one's going to be your neutral, that's okay. So you can see I've got 120 out the outlet, but then the question is, okay, if we don't know which one's hot and which one's neutral because we don't know who wired it or if it's wired correctly, how do we figure out who's who? That's where your ground comes into play. Now, if you don't have a ground present at the outlet, you're going to have to bring a ground to your testing area or hook an attachment to your lead and run it to a ground somewhere else in the house. Just be careful because if your body is the one that gives the electricity a direct path to that ground, that's a little bit 1-2 barbecue, and that's no good for anybody. So just be careful while you're doing these tests. So what you can do is you can use your probes to open the doors if you got little doors in there. Okay, we've got our voltage. We can take one probe out and we can put it to the ground. Okay, so if I have 120 volts between this prong and the ground, whether it's at the outlet or it's a separate ground, that's telling me that's my hot. And then I can move that little guy over like that, and that's in the left prong here to ground, and you can see a whole lot of nothing. So there's that. These leads aren't bad, but they're not great. Klein has some other leads that I really like that should be in the video description that have little alligator clamps that go with them that screw onto the tips here. I really like those. You can see that we're already in a low battery state. I don't know how this made it to market. Keep an eye on that battery indicator. Yeah, it's getting mad at me. It's like, hey, I've been on too long. I've only been on a couple of minutes. Volts DC, really straightforward. Red to positive, black to negative. And you'll get a measurement. So I've got 13 volts DC here. What happens if you do it backwards? Well, not a big deal. You're just gonna get a negative sign. Let's see, we can hold that button. Just gonna get a negative sign letting you know that the lead polarity is reversed from what it was anticipating. So if you're seeing that negative sign there and it's confusing you, that's what's going on. Just try switching your leads around. Take your measurement again. This next setting down here, this is continuity and ohms. It's gonna default to continuity. That's that little speaker symbol that you're seeing. And what does it do when it's in continuity? It should beep. Should be a solid tone. It's really struggling. That does not give me the warm and fuzzy. Man, I was really looking forward to this meter. Okay, should be a consistent tone, and that's gonna let you know who's who. So whether it's a ground wire or whichever wire, oftentimes our wires, get a little magic curtain here, our wires are hidden behind dashes, behind walls, tucked into places. And so usually we only have access to the actual terminals of the wires, the ends, right? So you can use continuity, especially if you got a whole bundle. Okay, that goes to there, but does it go to here too? No. What about this one? Go to here? No. Oh man. Because that black wire certainly goes to that terminal. The continuity is a little spotty on this thing. It could be the leads. First thing I do is get another set of leads for this thing too. Link in the description. So that's what continuity is for. You can use it to check your loads, like if you're testing the filament for a light bulb. Okay. And with this setting, you have your resistive setting. Now, any electrical load is going to have a certain amount of resistance. Resistance and continuity, kind of the same. Continuity is just telling you that there's a low amount of resistance. But with the resistive measurement, we can read things like electrical load resistance, or if for bigger numbers, we can read these resistors. So this resistor is like 326 ohms. If I keep going up, now we have a K there. So we got to pay attention to that K. That K is saying, take your value and times it by 1,000. K is for kilo. So take that value, times it by 1,000. The real value of that is 9,970. And then if we go up further, now we have a capital M, 1.045. M is for mega, or think of a million. So it's really 1,045,000. So that's something to keep your eye out for when doing resistive measurements. Next is going to be capacitance. Got two different capacitors here for you to check out. Let's make sure it's in the right setting. Okay, so it's going to default to capacitance. Make sure that your capacitors are shorted out before testing them. I've got this run capacitor out of like your home AC unit. And then I've just got this little circuit board capacitor. I'm going to show you how to test both of them. For the run capacitor for your AC unit, you're going to have 3 terminals, because think of it as like 2 capacitors that share one terminal. The common, that's what the C is for. And you can use your common lead, your black lead from your meter, put that on the common terminal, and then your red lead to one of the other terminals. And that's going to tell you, okay, there I'm seeing 5 microfarads. And then let's do it to the other one. Give it a minute to charge. 35 microfarads. And we can see on this capacitor, 35/5. It's saying one of them's rated for 35 microfarads, the other one's rated for 5 microfarads. So this one came back good. Let's take a look at this one. Pretty simple. It's got a little negative sign on the side here. Common to the common side. Red to the power side. And give it a second to chooch. There it's going. Oh, out of limits. Let's try that one more time. Out of limits. Okay, so the OL stands for open loop or out of limits. This is beyond the size of this capacitor is beyond what the meter is able to register. So it probably has a lower count. But if it was a smaller rated capacitor, it would be the same type of test. Okay, now we have Hertz and duty cycle. Hertz and duty cycle are really cool. Something that we can do is AC power coming out of the wall here in North America. It runs at 60 Hertz, and we can verify that with our meter. There you go. And duty cycle is that little percentage sign. And how are they related and what do they mean? So Hertz is the amount of times that something goes from on to off or plus to minus in a 1 second period. Duty cycle, which is always expressed as a percentage, tells us, okay, in the on to off position, how long is it in the off position? So you can have like a square wave just like this guy, and it's on 50% of the time and it's off 50% of the time. So if you were to measure its duty cycle, it would say 50%. Whereas this one, it's on for much longer duration, so it would say something like 80%. We used Hertz. I've got a little signal generator here. Let's just see what it says about our wave. I've got a 10K Hertz that my signal generator is putting out, and then I can hit the selection button and it's letting me know, okay, that signal is at a 50% duty cycle. Pretty cool. So that handles the right-hand side of the dial. Now let's get into the left-hand side of the dial. Things are going to operate a little bit different over here on this side of the dial. So remember what I said originally, 10 amps is the only time that you're going to switch your meter lead over to this other port. Couple things to note. It's going to default to AC, which is going to be good for most of you that are using this meter for probably electrical or HVAC work. But if you're using it for DC circuits or whatever, keep it in mind. It always, even if you're going from 10 amp to 10 milliamp, or from milliamp to microamp, it's always going to revert back to AC. So pay attention to that because it'll bite you. We're going to be measuring amperage or current. That's what the A is for. We're going to be doing this with DC circuits, but the principle is going to be mostly exactly the same. The rules that we're going to have to follow here. So something to think about when the meter is configured like this, when you've moved that red lead from here to here, you've changed the principles of the meter and how it works. So before, if we were going to make a voltage measurement, we could just go like that, right? You can't do that in this configuration because we've just turned our meter leads into a jumper wire. There's no difference between these leads and this jumper wire. And so if we were to go and do a measurement like that, well, then we would short out this battery and this wire would get really hot. That's no good, right? We don't want that. So we need to make all of our measurements in series, where before we were making them all in parallel. We have a load, we have voltage being supplied, but we have an incomplete circuit and we want to make a current measurement of this load. So remember how I said before, our meter leads are no different than this jumper wire. Well, to complete our circuit, we could just do something like this, right? Well, we can take advantage of the fact that our meter leads are now a jumper wire, and we can do the same thing, except now we're going to be able to get a current measurement. Just like that. We got to pay attention. It's on AC. I've got a DC circuit here, so I got to pay attention, make sure it's on DC. So I can see that I'm measuring, or this light bulb is drawing 2 amps of DC current. Okay, so now we've got our circuit open in a different spot. Before we had it open on the power feed side, but now it's open on the common or the ground side of our little DC circuit here. And you might be wondering, can we measure the current on this side of it? And yes, we can, because current has to flow through the whole circuit. It doesn't get consumed by the load. So we can also measure it on this side of the circuit. So notice my leads though. Before I had my red lead on the power feed side and my black lead toward the load. And this time I have my red lead on the load side and my black lead returning to the power source, right? What if we made this measurement backwards? What would that look like? Well, it's kind of the same exact thing as making that example that we did on the battery. Because it's DC, because it's directional, we're going to get that negative sign. So if you're doing a current measurement and you see that negative sign, it's just saying, hey, the flow is backwards from what the meter's anticipating. You can try flipping your leads around, okay? So it's not that big of a deal. Let's try a different load. Got a little motor here. Very cool. Okay, this time you can see we're making a much smaller measurement. And instead of saying, oh, this is 0.449 volts, we could say it's 449 millivolts. We're starting to get into the millivolt range. This is where we want to start looking at our meter and what it's rated for. The port that we're in now is rated for up to 10 amps of current. It's got a little 10 amp fuse in there. The next port is rated for 500 milliamps. So if we're going to make small measurements, it needs to be less than 500 milliamps. But something that we want to think about is that we have really special fast-acting fuses in there. And just because our load is under 500 milliamps, that we would necessarily want to use that smaller milliamp setting. And that's because when we first turn on an electrical load, we have a portion known as the inrush current. And if the inrush current exceeds that 500 milliamps, which it likely does with a component like this, an electrical load like this, there's a chance that you could blow that 500 milliamp fuse in that setting. So it's something that we just want to be cognizant of when we're making current measurements, is we always want to make sure that we're super well under the rated value so that we don't don't blow that special fast acting fuse. So let's keep going into smaller and smaller measurements. Okay, I know this is set up a little bit funky, but the principle is exactly the same. I'm just completing the circuit with the meter and taking a measurement with it. So let's try, let's see, we'll unhold that. Okay, now we're starting to get really, really small, right? 0.036, so that would be 36 milliamps of current. So now I feel really confident that I can step this down to the next setting, retake my measurement, and get something a lot more accurate. So I'll step this down. It doesn't say lead, but it should, because now we can see that this one is illuminated and this one isn't. So we'll change this over. Remember what I said before, make sure we hit that selection, it's in DC mode. What happens if you left it in AC mode? Let's see what it looks like. It's going to show basically 0. Okay, so you'll be very confused and you'll be like, oh, where did my electrical load go? So we'll hit that. Now we can see, okay, 37 milliamps DC current we're measuring. And we can keep walking it down. 12 milliamps. Okay, now we're getting really small. We're getting into microamp territory. This is 1.19 milliamps, or another way that we can think about this value is it's 1,190 microamps. So now I'm like, okay, I can go even further down and get even more accurate. I can go down to the microamp setting and get more resolution in my measurement. Gotta remember, boom, DC. Okay, 1,194 microamps is the unit that we're measuring in. We can step it down one more time. 121.8 microamps. That's an incredibly small value. I love it when meters can measure in microamps, AC and DC, pretty clutch. Range is to make it a manual ranging meter if you wanted to. Min and max are the min and max values of whatever measurement that you're trying to set. And then we went over the selection button. So I think that's everything that we need to go over. If you got any questions, let me know. If you guys are learning this stuff, I've got a bunch of different videos and shorts on different electrical concepts and a bunch of different meters and different electrical projects if you're trying to get ideas for different projects for yourself. So anyways, I hope you enjoyed, and I'll catch you on the next one.